Hello, ladies and gentlemen, and welcome back. We're looking now at C2 on our 2014 Open contest. The line L, given by, so this is in, actually it's not even in standard form, but 5y plus 2m minus 4x minus 10m equals 0. In the xy plane, intersects the rectangle with vertices the origin, 0, 6, 10, 6, 10, 0. At D on the line segment OA and E on the line segment BC. So these are intersection points, and these are, just a real quick sketch, 0, 6 would be up here, 10, 6, 10, 0. Okay, so we got a nice little rectangle. So our line hits somewhere here with D, and then maybe somewhere here with E, or something like that, if it's, alright, upward sloping or something like that. I mean, E could be down here or something like that, but we definitely know it hits on the line segment. Okay. So what have we got? A part. Show that M is between 1 and 3. Well, the fact that D has to be between O and A and that E has to be between B and C sort of limits the range of values that we can have here, and it's going to end up limiting this M, I would assume. So, what can we say? Well, I know that D has... Well, actually, we can start writing this down. But D is on OA, so has an x-coordinate of 0. And so we can say something like, say D is at 0D. I don't know exactly where it is, but then I know that D is between 0 and 6. Similarly, E is on BC, and I think that was 10, an x-coordinate of 10, yes. And so has an x-coordinate of 10. And so we might say something like E is at 10 little e. And again, we have this nice range. E is between 0 and 6 because it's on the segment OC, not the line, or sorry, not OC, on the segment BC, not on the line BC, which would allow it to be sort of extended beyond. So we definitely hit the sides of this rectangle. All right. So I have a nice little range of values for E, but then what have we got? We've got a nice little formula. It starts 5y, I think it was plus 2m minus 4x minus 10m equals 0. Let's just double check if that's correct. 2m minus 4 minus 10m. Okay. So D and E are on this line. So that means D and E both satisfy this relationship. So I think we should be able to find a way to get M in terms of D or E or something to that effect. Okay, that's the idea. Yeah, okay, so I'm going to use D first, so that way I can ignore the X there. So 2m minus 4 times 0 minus 10m is equal to 0. So 5d is equal to 10m. And since d is between 0 and 6, then 5d is between 0 and 30. And so m, which is equal to, 10m is equal to 5d. So 10m is between 0 and 30, and so m is between 0 and 3. Now, I think we wanted m between 1 and 3. Alright, so I've got part of this expression. Great. So now I think if we plug in e, we should get the rest of this. So 5e plus 2m minus 4 times 10 minus 10m is equal to 0, so 5e plus 20m minus 40 minus 10m is equal to 0. Okay, so we'll keep the 5e minus 40 over here, and I'll say equals minus 10m. Actually, I think I'll rearrange that and say 40. So let's finish erasing here. I'll keep the 10m over here and bring this over as 40 minus 5e. Alright, but again, we have a range of values for e. So 5e has to be between 0 and 30. So negative 5e is between negative 30 and 0. Add 40 to both sides. 40 minus 5e is between 10 and 40, but this, is, of course, is the same as 10m. So m is going to be between 1 and 4, and there's the other part of our result. Oops, not E, 3. Alright, there we go. So that's A part, not too bad. We just sort of plugged our points into the formula, rearranged, and since we had an inequality for the range of the y coordinates, we could get this inequality for the m, giving us a range of values for m. Alright, so that's A part. B part, show that the area of quadrilateral ADEB is 1/3 the area of rectangle OABC. Alright, let's draw the picture here. Let's get a better y-axis than that. There we go. Alright, that's good enough, I guess. So O is here, we'll put A up here. B is over here. C is here. Now our line comes in something like this. D is here, E is here. And they want ADEB. So this needs to be 1/3 the area of the rectangle. Obviously my picture isn't accurate, but alright. So we can figure out the area of the big rectangle. So OABC, or the area of OABC, it's 10 by 6. So it's 60. So I really just need to show that the area of this figure, which I guess is a trapezoid, because we've got two parallel sides, so maybe I can use that. Alternatively, I guess I could figure out which one's higher, E or D, and chop off this right-angle triangle here. But I don't want to have to figure out which one's bigger, E or D, because depending on the m value, that might actually change. And the way the question is phrased, it looks like no matter what m value we pick, we should get 1/3. Right? Yeah, 1/3. So really what I want to show is that this area here is 20, because 20 is 1/3 of 60. Alright, so how on earth are we going to do that? Well, AD and BE, we want to get those lengths, so might say something like ABED is a trapezoid. AD is parallel to BE. It has a height of 10. And so I just need to figure out these sides here, which I guess using our notation from the first part of the question would be 6 minus D and 6 minus E. So the area of ABED would be 1/2 the height. Here I'm using the formula for area of a trapezoid. 1/2 the height, 10, times the sum of the parallel sides. Okay. So we could simplify that to be 5 times 12 minus D minus E. Or I'm going to rearrange this as D plus E because I think that might be easier to work with. So what do we need? I need d plus e to be 8. If I can show that, then we're good. Okay, but how can we show that? Well, we should be able to relate the slope of this line in terms of say, maybe some m to d and e, or something to that effect. So, what can we say? And should we be using part A to do any of this? Show that the quadrilateral is 1/3. Are we given any other information? Not really. So I think what I'm going to do is I'm just going to plug both expressions into the line here. I'll get a 5d and a 5e, and I think I'm going to add these two up. So plus 2m minus 4 times 0 plus 2m minus 4 times 2. Yeah, because it's going to be 40 divided by 5 is 8. So this will work out nicely. Because the minus 10m and the minus 10m will cancel out with the 20m. So we'll get 5d plus e. Nothing happens here. These two at the end combine to a minus 20m. And this will be plus 20m minus 40. So now the 20m's will cancel out. We'll get 5d plus e is equal to 40. So d plus e is equal to 8. So the area of ABED is 5 times 12 minus d plus e. 5 times 12 minus 8. 5 times 4. 20. 20 is indeed 1/3 of 60. So the area of ABED is 1/3 the area of OABC, just as required. Alright, C part. Determine, in terms of M, the equation of the line parallel to L. What's L? L is the line that we were given in the first place. Parallel to L, so has the same slope, that intersects OA at F and BC at G. We call that E and that G. So that quadrilaterals ADEB, DEGF, FGCO have the same area. So 3 quadrilaterals breaking up this rectangle, they should have the same area, which would be 20. Okay. So to start off, I'm going to draw just a quick picture. So put B here, put C here, A here, D here. And then we'll say something like this. So E here, D here. And so we've got this line L. Now we want another line parallel. And we get a G here and an F here. So area of, oops, this is not a D, this is an O. Area of OABC is split into 3 equal parts. So I need each quadrilateral, let's say, to have area of 20. Now, by B part, ABED has area 20. So it suffices to find an M so that, what's the bottom one called? OFGC. So we just need that one to have area 20. We know this has area 20, and if we said that this one has, if we were able to show this has area 20, the total area of 60 would mean that we got 20 left over here. And you could write that down if you wanted to, but I would say it's probably clear. Okay, so this is fantastic. Now, how do we make a line parallel to L? And you might be a little more comfortable with y equals mx plus b sort of stuff. So a line parallel just has the same slope. Okay, but look at what we've got here. We would want to keep the y over by itself. The 10m divided by the 5 becomes our b. And then our x stuff comes over here, flips a sign, so 4 minus 2m, and it also divides by 5. So we need to keep the same slope. Okay? And, you know, if you know standard form, you know that we could just say, all right, we need a different slope, or we need the same slope, we need a different y-intercept. So call it f. Incidentally, this says that d is going to be 2m, but of course we could have realized that a while ago. Yeah, we could have had d is equal to 2m from here. But we didn't need it at the time. But, you know, if you got the same slope, you just need a different intercept. But, of course, we could have just jumped straight to this. And so, to keep the same slope, you just need to keep the coefficients of the x and the y the same. And so you could have just jumped to this right from the start and didn't need to write any of this. But that's if you're comfortable with standard form of lines. I know not everyone is. Most people are more comfortable with y equals mx plus b form. And that's okay. Anyway, so, which form do I want to proceed with? I feel like using the standard form one. I'll keep the 5f in there in case you want to compare at the end if you'd use the y equals mx plus b form and you want to compare f values or something like that. But really, we just need to figure out f. The m is sort of, well, that's not true. We need to figure out the m value. F will likely be in terms of m, and we'll go from there. Now, OFGC is also a trapezoid. And we'll say f has coordinates 0, f, and g has coordinates 10g. And f and g are both between 0 and 6. Not that I think this will actually impact us at all. Okay, so there we go. So the area of OFGC is 1/2 height, which will still be 10. Will still be a height of 10. And now it's f and g that we need, so times f plus g. So we just need to figure out an f plus g. Now we can figure out g in terms of f, and then we should be able to get everything in terms of m somehow. And we're going to use sort of the same trick. So 5y plus 2m minus 4 times 0. It's a minus 5f, isn't it? Yeah, minus 5f. Oh yeah, I should probably write something like, so 20 is equal to 5f plus g. We need f plus g to be equal to 4. Okay. So that's got to be equal to 0. What's our other one? So we get f here. We get g here. Minus 5f is equal to 0. So we add these up, we'll get 5 times f plus g. I want that to be equal to 4. Plus 20m minus 40 minus 10f. Okay, but f plus g is 4. So we get 20 plus 20m minus 40 minus 10f is equal to 0. Now we should get a relationship between m and f. And so we can 20m is equal to 10f plus 20. Divide by 10, 2m needs to be equal to f plus 2. Okay, and what are we actually trying to figure out? Determine in terms of m the equation of the line L. Okay, I thought I had to solve for an m. I don't. So we really just need that f there. So f is equal to 2m minus 2. So that should suffice. So what's the equation of the line? Well, it's 5y plus 2m minus 4x plus, now, oh, it was minus. So I had minus 5f here. If you'd done y equals mx plus b form, you'll just put your plus f there. So this will be minus 5f equals 0. And simplifying things a little bit, we'll get plus 10 minus 10m equals 0. Okay, so that's suspiciously similar to what we had up here. Of course, the slope parts need to stay the same, but we really just needed to add 10 into our expression. And yeah, that's really all there is to it. I wonder if there was a cleaner way to see that you just need to add 10. I can't think of anything off the top of my head. Now that was C2. You may want to double check your work, especially if you're a little uncomfortable switching around between forms or things like that. I'm happy with the result there, and so my final answer would be this. But of course, it's a C part question, it's C2, so we do need to have all our justification in there. But that's about it. So we're halfway done the Part C questions. Up next will be C3. So feel free to have a look at that before joining me in the next video. Until then, take care.